Coupling is when two classes are linked in such a way that a change in one requires a change in the other. If two classes inherit from the same parent, then a change in one may require a change in the other. When we have several inherited classes that are coupled to a point that they are really too different to be fundamentally linked, that is when we want to decouple the objects and introduce an abstract class, as was done in the foxes and rabbits simulation example. Let's place common fields of both types of animals into an animal class, and we can rename the actions of the animals, run and hunt, to act to enable decoupling of the simulator class. Rabbits and foxes both do similar things, but they behave differently. Eating is different, moving is different, and deciding to use act as a method to encompass what each animal subclass will do will streamline the application. In the last chapter we discussed method overriding, and this is an option in this scenario. We could write an act method for animal and then override it with each new animal subtype we create. But there is another option. Making animal an abstract class allows us to create abstract methods in animal that can be utilized from each of its children, but in a way that doesn't require overriding. Since, in our example, we will never have an animal object created from the class, this is the perfect time to use an abstract class for animal in order to simplify the simulation. The act method in animal is now an abstract method since there is no obvious shared implementation. The animal class can also be abstract because there will never be an actual animal object created, only subclasses of the animal class. You can see how there can be further abstraction with the addition of an actor class, which would allow us to add a hunter object to the simulation.